And in other news, scientists at 10X Lab believe that they may have created the world's first sentient computer. This new thinking machine was repeatedly tested using the Turing test. This test, devised by Alan Turing in 1950, says that if a computer can fool a human into thinking that it is another human just as often as a real man could, then it is intelligent. Alan believed that mastering language was indeed equivalent to intelligence. The scientists carried out this experiment by having a test subject communicate with two other entities via a computer text terminal. One of these entities was the computer, and the other was a balding technician. The tester's job was to figure out which was which. After repeated experiments, the computer was able to fool the testers approximately 54% of the time.
Whoa, dude! Thinking computers! That's awesome!
I don't know. I don't think that passing the Turing test necessarily means that the computer is intelligent.
But dude, they're like scientists, man! They know what they're doing!
True, but that doesn't mean that they're right. The Turing test has some problems, you know.
Prove it, man!
Well, if you insist.
Whoa! Dude! Where are we?
We are in the thought experiment.
The what?
My thought experiment. Every philosopher worth his salt always keeps one handy, just in case. We use these to think up arguments and objections.
Whoa!
Now, I can't give you a 100% airtight proof that the Turing test is wrong, but I think I can give some strong arguments. The first is called Searle's Chinese room. Suppose we have a room with a man inside. Through a hole in the wall, he is being slipped pieces of paper written on in a language he doesn't understand. In this case, Chinese. His job is to slip out a response written in Chinese. As you can imagine, this is rather hard since he doesn't actually understand the language. Fortunately, he has a book of rules which show him which answers go to which message. Suppose the rulebook gives perfect responses for every possible message that he could receive. The man inside could fool anyone on the outside into thinking that he speaks fluent Chinese. However, we know this isn't really true. The man doesn't actually understand Chinese, he's just matching symbols and shapes.
But what does this have to do with the Turing test?
This is just how the computer works. It receives input, the messages, its software checks the rules it has been given, the rulebook, and then returns output, the answer, to the user. Just like the man who didn't understand Chinese, the computer doesn't understand what it is saying. It's just matching patterns using the rules it was given. Philosophers refer to this as syntax versus semantics. Syntax is the pattern, and semantics is the meaning. Computers get syntax, but Searle's Chinese room shows that even if they could manipulate syntax perfectly, it still doesn't mean that they understand semantics. Let me explain it again as an argument. 1. If the Turing test proves that a computer understands a language, then the man in Searle's Chinese room would know Chinese, as they are doing essentially the same thing. 2. However, as Searle's Chinese room shows, the man doesn't understand Chinese at all. Therefore, the Turing test doesn't prove that a computer understands a language. Since Turing thought that understanding language was equivalent to intelligence, Searle's Chinese room shows that the Turing test doesn't prove that a computer is intelligent. In other words, passing the Turing test doesn't necessitate understanding. There doesn't necessarily have to be any intelligence involved on the computer's part. The program isn't enough.
Hey dude, it looks like that computer from Netscape.
We're on a bit of a budget. This is actually Block's Conversational Jukebox.
Conversational what?
Block's Conversational Jukebox. It's another objection to the Turing test. Suppose we took every single combination of sentences that was under an hour long. We'll call these speakable strings. For example, a speakable string could be something like, "Hello, what is your name? My name is Fred. What do you like to do? I like to talk philosophy," etc. Or it could be something nonsensical like, "What is your favorite musician? The rain in Spain falls mainly on the plain. Roadrunners like cheese." As I said, a bunch of sentences that altogether are under an hour long. But suppose then we kept the speakable strings which could be considered a conversation in which at least one person was making sense and discarded the rest. We can call these remaining strings smart speakable strings. Now, this would still leave us with an incredible amount of data, but for sake of argument, suppose we could record it all and store it in this jukebox. The way this jukebox works is that when someone says something to it, it looks through all the smart speakable strings and finds those which begin with the sentence spoken to it. It would pick one of these strings at random and play back the second sentence. Then, if the person says another sentence, Block's conversational jukebox looks through all the smart strings again. This time it looks through all the smart strings that begin with the 3 sentences spoken so far. Then it picks one of these smart strings at random and plays the 4th sentence. How about you try it and see what I mean?
Name a president of the United States of America.
Now wait while the jukebox finds all the smart speakable strings that begin with that sentence.
George Washington.
What did he do?
Now the jukebox is looking for a smart string which starts with, name a president of the United States of America, George Washington, what did he do? When it finds one, it'll play the 4th sentence in that string.
He cut down a cherry tree.
Of course, the smart speakable sentences don't always need to be factually correct. But do you see what I mean? All this machine is a microphone, a speaker, and a simple matching device. With these, it could theoretically carry on perfect conversations. This means that it meets Turing's criteria for intelligence, and yet you can see that it's just spewing forth semi-random sound waves. It doesn't understand the meaning behind what it says.
Whoa!
Yep,